Everybody's Tyler here at the Indianapolis Speedway Signature event, checking in 99904W Wooosh, and holy cow, the pings on Discord are nonstop for this team. Wooosh here, obviously one of the big things we're going to be diving deep into is their simulation programming. I can't wait to talk more about that, but they got a lot of great stuff physically on the robot too we'll be talking about. Getting a brief overview on some of the different attributes and aspects they've been working on. And of course, like I said, this sim programming, you really got to check it out. So let's learn more about this team coming up here on Pits and Parts. Carson, let's break down this robot a bit more. Talk about on here, you got so much delrin on this robot, so I'd love to hear about the delrin intake. And you're also rocking a passive hang too. Tell me more about that.
So we actually have a completely delrin structured intake. The entire arm right here, it's hard to see, but it is actually just completely delrin. There is no metal running along here. So we did this because most teams, when they have a metal-based intake, when they get hit in the front with a lot of force, it actually causes it to bend and then fail for the rest of the match. We adapted to this by having a complete delrin intake, which A, reduces friction, B, reduces weight, and C, is able to bend out of the way when we're hit. So by bending out of the way and being able to flex back like how plastic does, it completely, it perfects our intake and it makes it so it's super consistent in all of its functions.
When did you make that change, by the way, for your robot?
We actually, when we were designing the robot, we had problems on the last robot, so we decided, hey, why don't we throw in a delrin intake in this, see how it works, and it worked perfectly first try.
Dude, that's awesome. Love it.
We got lucky. So another thing on the intake, we also have a lift. So this lift lifts perfectly off of the delrin intake into the robot here. Can you spin the intake? So it actually picks it off directly off the ground straight into the robot without having to drop the intake at all, which makes it so the first ring isn't even at risk of being picked up. Another thing I want to talk about is actually our passive hang. So this hang is completely passive. There's no pneumatics, no anything. So other robots have a lot of problems with pressure imbalances, pressure differences. Like, there's not going to have the same pressure at the end of every match. It's very easy to run out, especially in this game where you need to be light and fast. It's hard to have two tanks. So this hang is actually just rubber banded up to our wall stake mechanism. So when the wall stake mechanism is down, it is completely down. This can go under the bar just fine. But as soon as we lift it up, it is set perfectly for hang, and we can hang right off of that.
Very cool, Matt. And as we move on here, Charlie, we talked about alignment on your robot. You're using delrin in so many different spots of your robot to get that alignment going. So talk to me more about what you're doing exactly for that.
Yeah, we use delrin in a few different places here. One of our two main ones is on the back here. You can see how it's slightly inclined, set in. And this allows it, whenever the goal comes up, it allows it to center on this. It also allows us to, when we're going up to the Alliance wall stake, it centers us on the wall stake, allowing our intake to score better on that. Also, one of the big parts is on the front of the robot. Along with the Lexan sides, it also has this Lexan top plate. It allows us to line up onto the wall stakes, and then along with Lady Brown, it allows us to consistently score on wall stakes very quickly.
Now, how does your from your Lady Brown and scoring wall stakes, can you just overview how that all works too?
Yeah, here, I'll show you real quick. So it has three different states. It sits at the bottom, it sits here where it gets it, and then it's on a macro, so whenever he clicks it, it puts it out directly to the thing. And when we're lined up with this is the perfect height where it perfectly slides on top of it.
Mechanically wise, are there any potential future changes your team's looking at making for your next set of events?
One of the big ones we're planning to change, we're planning on maybe going into a locking and claw mechanism. Like Carson said, we're really worried about air and keeping light, and a locking claw would help us still have a strong grip on the goal while also not wasting air.
Arjman, we got to take a look at the sim programming that you're doing here. So talk to me more about, why'd you even go this in the first route? But I'd love to hear some of the benefits that your team has seen out of this. And then maybe a little bit of spoiler here, this might be available for teams to check out open source later on too, right?
Yeah, that's right. So this all started last year when at Worlds we decided that our brain was not going to work, and we needed programs, and we went all the way to division finals, and then we still didn't have a program, so we wrote our program on the division final field. The refs didn't really like that one, so we decided we needed more time when we didn't have access to a field, but we still wanted the program. So I came up with the idea to work on simulation programming. At first, it was going to be a physics simulator. That was when we were trying to get the tri-balls out of the corner, and that was a big problem we ran into last year. So we thought maybe that'll happen again this year, and we didn't have that problem this year. So we were able to make it without the physics simulator. It simplified things a lot. And now that we have it, we're able to find what we think are the best mathematical routes for skills and autonomous periods. We can use we went through a bunch of input iterations. At first, it was where we were manually inputting the locations we want to go to. Then we went into it'll automatically adjust the angle of the robot so it's at the right angle. And then now we're up to the point where it'll automatically cycle through different possible iterations of the skills route and of the autonomous routes. We're able to also adjust what locations we want to go to. So if in an autonomous you want to go to 5 rings, you can go to 5 rings. If you want to go to 3 rings, you can go to 3 rings. And you can pick which ones you want to do that with. Here's a preview of one of the skills that we found. This one was pretty nice. We used the same mathematical formula that delivery companies like UPS and Amazon use when they're trying to deliver packages to customers. So it's called a vehicle routing problem, or a VRP, and it takes into account 2 things in our simulation. We have travel cost and turn cost. So the travel cost is how far the robot has to move, and the turn cost is how many degrees the robot has to turn. So these 2 added together with scaling will give us the total cost, and we can compare routes quantitatively by comparing the total cost. And we can create a leaderboard and set how high or how good of a route we want to find. And that's really helped us get our routing down for autonomous skills, and that's the same route we use in our driver skills.
What are you doing for localization to make sure that what you're doing on here actually does translate to the field?
So when we were actually making the program at first, one of the big problems was the scaling. So our robot is obviously it changes as we're still building, but when we took a picture of the field that we use on the simulation, we had to make sure that our robot was the right aspect ratio to the field. So we had to count pixels and make sure that from the front of the intake to the back of the clamp was the accurate distance and the accurate scaling. So that was a big thing.
We talked about that. This might be something that is released that other teams might have access to later on, maybe post-season or something. Where might somebody be able to follow you to see where that comes out later on?
Yeah, that's right. So after we have finalized the simulation, we will be making this program open source so that other teams can use it in this game and in future games. Our current plan is to have it released by January, and you can probably find that on our Instagram page, hopefully at the start of January.
What's your Instagram page name?
It is 99904Woooosh.
Well, speaking of that, Woosh, first off, what an inspiration to be able to provide the teams mid-season as well, too. I think it's a really boss move that you're doing, so super cool with that. Love the robot as well, too. Good luck here, of course, at Speedway, but you got a lot of great events coming up. We can't wait to see how your team continues to evolve through this season as well, so we wish you best of luck here, and thanks for being such a great inspiration to the teams out there in the VEX community. Appreciate it, guys.
Thank you.
Thank you.